Okay, let's look at example 4.3. In example 4.3, we have a loading car at rest on an inclined plane. The gross weight of the car is 5,500 pounds and it's applied at G. So right here, oh, that was jumpy. We have force here of 5,500 pounds. And we are supposed to find the reaction at that wheel, the reaction at this wheel, and the tension in this cable to hold this thing in equilibrium. Okay, so how can we do this? Well, we need to draw a free body diagram. I kind of sketched up almost part of a free body diagram there, but instead I'm going to make my life a lot easier. And I'm going to draw I'm going to rotate it. Okay, so we have a wheel here, we have our car, right? So we have a tension coming off this way, I'll call it T. Here I'm going to call this point A. I have an unknown force in that direction. I have an unknown force in that direction, B. And here at the center of gravity, what do I have? Well, I have gravity acting off in this direction there, and that's 5,500 pounds. So I'm going to call it, that has a certain portion of it, W in the X direction, the weight in the X direction, and the W in the Y direction. So just for clarity, let's just define those right off the bat. So we're going to say W in the X direction is equal to the weight, which is 5,500 pounds, right, times cosine of, what is it? It's rotating through 25 degrees, so 25 degrees. So weight in the X is equal to 4985. And weight in the Y is, 5,500 times sine of 25, so that's equal to 2324.4. Okay, so now we have our three equations. What are our three equations? Well, we have sum of the forces in X equals 0, sum of the forces in Y equals 0, and sum of the moments equals 0. Well, which one do I want to use? I'm going to say, let's start with, just in general, start with the easy one first. Get the ones where you can find a solution quickly, early. And so to me, I'm going to start with the sum of the forces in the X equals 0. Why am I going to do that? Well, because then you just simply have the tension must be equal to the W in the X direction, which is equal to 4985. So tension is 4985 pounds. Boom. Okay, so there's that. Now we need to figure out the next one. So let's say, do we want to do the sum of the forces in Y? Well, we have two unknowns in Y, and so although it would work, it'd get you in the right direction, you're going to have two equations, and so eventually you're going to need to get another equation also. So instead, let's take the sum of the moments. And let's pick somewhere where something cancels out. So I'm going to say, let's take the sum of the moments about this point, about A. Okay? So let's say sum of the moments about A is equal to 0. Okay, well, in that case, we have T times this lever arm, which is this distance right here, right? And that's giving us 24 inches. And then that's going to make it rotate counterclockwise. And B times its lever arm, which is 50, the distance from here to there, right? That's going to also make it counterclockwise. And then we need to subtract off the weight in the Y times this lever arm, which is 25, because that's going to make it rotate the other direction. And we also need to subtract off weight in the X, that's a W, in the X, times this lever arm, which is 30. This distance right here is given as 30, and that is equal to 0. Well, we know T, we know WY, we know WX, and so you end up with B is equal to 1760.4 pounds. So we know that the reaction here at B is 1760 pounds. Now, we have two out of the three unknowns, so basically almost anything is going to be easy to do. We can take the sum of the moments out B, and that'll give us A. We can take the sum of the moments anywhere. But quite frankly, at this point, it's probably easiest to see the sum of the forces in Y. So I'm going to say the sum of the forces in Y equals 0. And so what do you have? You have your up forces equal to your down forces. So A plus B needs to be equal to the W and the Y. So A is equal to the W and the Y minus B, okay, which is equal to the 2324.4 minus 1760.4, so it's equal to 564 pounds. And there you got it. So the reaction at wheel A is 564 pounds. The reaction at wheel B is 1760.4 pounds. And the tension in the cable is 4985.